Okay, so acceleration. Acceleration is nothing more than just a change in velocity. For this ball to go from rest to moving, I have to accelerate it. During the time that I'm pressing on it, it is accelerating. Once I'm no longer pressing on the ball, it's more or less traveling at a constant velocity. If I throw this ball across the room, during the action of throwing it, I'm going to be accelerating the ball. It's going to start moving faster. As soon as I let the ball go, it's going to continue traveling in a horizontal direction at a more or less constant velocity. Now, air resistance is going to make it slow down somewhat because of friction, but aside from that, it's going to more or less travel at a constant velocity because it's still a fairly slow moving object, even if I throw it really fast. So whenever you throw something, high acceleration period because you're going from rest to a really high speed, and then it's constant velocity until it hits something. The vertical component to it is different. If I take this ball here and it's sitting at rest and I throw it into the air, I'm accelerating it upwards. The instant I let it go, it's immediately going to start accelerating downwards, which shows as it slows down and then it speeds up as it comes down until something stops it. Otherwise, it would continue to go faster and faster as it traveled downwards. So the same thing holds true whenever you throw something. If I throw this ball, it's going to accelerate in the downward direction at the same speed no matter what. So whether I throw it really slow or I throw it really fast, it's still going to drop to the ground at that speed. The angle that the ball actually takes is going to be a function of how fast it's going in the horizontal direction compared to the vertical direction. Gravity, from our frame of reference, will always accelerate everything down at 9.8 meters per second, or about 32 feet per second. So that means every second, this is going to go, if nothing else is stopping it, it's going to add 32 feet per second to its velocity in the downward direction. So if I throw it up into the air at 32 feet per second, after 1 second, it's going to be at 0 feet per second. And then after another second, it's going to be at 32 feet per second in the other direction. And same thing with angular motion. So if this ball is sitting at rest and I spin it, it's spinning at more or less constant velocity with, but it has a slow deceleration because of the friction with the surface. But the period where there's a high amount of acceleration is when it goes from rest and I quickly accelerate it to that speed, and then it takes several seconds for that speed to decay back to a resting position again. So when we talk about measuring things like acceleration, so if this ball goes from rest and then it speeds up, and at the end of that period it's going at 3 meters per second here, and it took 1 second to get from 0 to 3 meters per second, then we say the ball had an acceleration rate of 3 meters per second squared, because every second it increases its velocity by 3 meters per second. Now, if we measure that, what that acceleration looked like on smaller and smaller time intervals, we find that, hey, it wasn't a uniform, even acceleration. There's probably a period where maybe there was some sharp acceleration and then it kind of dropped off. Maybe there were some other small periods, if you were pushing on it or something, where there are sharper periods of acceleration. But in general, you're just looking at, how much did the velocity change over what period of time, and then that gives you your acceleration rate.